I am. Hang on a sec. Maybe that'll be the saving grace. Oh dear. Oh dear. Hang on a sec. We are.
What? I don't know who's heard what. So this is a welcome to the show, Rory. This is how we operate.
Yeah, yeah, exactly. So for all of you who are expecting your first debate to be a professional one, sorry.
No, it's all good. All good.
It's usually much worse than this. This is going relatively well so far. What do you think, Kat?
I think we're smashing it. I think we're absolutely smashing it. This is awesome. Right, so I don't even know who heard what then, but I was giving out the winning lottery numbers for this week. And now I've lost the Zoom thing on the screen, and then we're back. Are we live?
I think so. I think so.
So this week we have a bit of something different because I messed up a little bit, and I'm going to tell the same joke for the third time on the trot. Creaky's going to kill me. The original debate was supposed to be with the man on my this side here. We'll let him introduce himself in a minute. Against the man we've had on before, Great Believer down at the bottom on Flat Earth. And when I said to Great Believer, I said, "Are you ready for the show?" He said, "Yes." He said, "Me and my perspective will be there." And I thought he meant me and my viewpoint on Flat Earth will be there. But actually my perspective is a real person. So we've got two. So for for Turbo Brain's first debate, it's a 1-on-2. I'll let Turbo Brain introduce himself, and I'll let the others introduce themselves. We'll break down the debate, and then we'll just crack on.
Hi, everybody. I'm Craig. I'm known on Twitter as Great Believer, and the second time I've been on the show. I really enjoyed it. I mean, it wasn't hostile at all, and everybody was decent, so I appreciate that. And you guys didn't have much, you didn't interfere, you just let the debate go on, and I appreciated that. And you didn't let your own biases come and influence anybody else's thoughts either, so I also appreciate that.
Well, thank you. We'll get the same today. So go, Rory, do you want to introduce yourself, and then we'll go to Turbo Brain?
Hi, everybody. It's Rory Cooper. I've channeled my perspective. I've been discussing topics based on a non-rotating flat Earth and creating videos and animations to get my viewpoint. And the principles that I expound on are basically found in art. And these help me to understand that the Earth, it's flat and it's not moving.
Brilliant. And Turbo Brain, do you want to introduce yourself?
I'm David. I live over in the southwest of U.S. I'm definitely on the globe side, and I have a master's degree in mathematics, statistical analysis. So I know a lot about data, and I've taught at university, so I may be a little long-winded. I guess that's enough for me.
And also a long-time subscriber of mine. I remember seeing in the comment section, I think, since pretty much I started. So thank you for that as well. Creaky, is there anything you want to say before we kick off?
I'm fully concentrated and ready for action, and I feel it's only fair to point out that your efforts to point around the screen earlier on were in vain because I have us in speaker mode. But I think you can only see that my end and on the live stream.
Oh, brilliant. But, well, never mind.
Either that or you were trying to do the YMCA. I'm not sure. We'll take it to a vote later.
So, we never decided who was going to go first with sort of like the little opening. Rory and Great Believer, have you both brought a bit of an opening statement? Have you got one each, or have you got something joint?
I don't have an introduction per se. We just let the conversation go, and if the Turbo Brain and his mathematician wants to have an opening debate or facts that he has against the flat Earth, we're welcome to hear that. I don't know about you, Rory.
Yep. Yeah.
Okay.
We just get to ask questions. and let's just see where the discussion goes. And if we ask questions, let's just see what happens. Yeah.
Okay, so we'll pass that on then to David. He can make his opening statement, and we'll just take it from there, back and forth after that. So, David, off you go, sir.
Okay, I have I can talk about curvature. I have a photo from space if you guys want to see that. I know something about surface area, rotation. I can show you that the Earth is rotating. The revolution around the sun, stars, sun and moon, sunrise and sunset, Polaris and the sun, satellites, at the atmosphere, winds, Coriolis force, and ocean currents, black swan, gravity, magnetism, the second law of thermodynamics. I can talk about NASA.
Right.
And that's about all I have points for. If you want to talk about something else.
Yeah. So could I, Turbo Brain, if I could ask you a question?
Okay.
The Coriolis effect,
Yeah.
right? So where is it?
The Coriolis effect is caused by the rotation of the Earth.
Right. So where do we observe it?
We observe it in the way the prevailing winds work, hurricanes, tornadoes,
Right.
the ocean currents. All of those are affected by Coriolis. You notice that in the northern hemisphere, hurricanes rotate counterclockwise. In the southern hemisphere, hurricanes rotate clockwise.
Yeah.
Hurricanes never ever cross the equator. If you look at a map of every hurricane, there's not one that has crossed about 5 degrees. There's just a little blank spot there around the equator.
Yeah. Yeah. So the problem I got with the cyclones, we call them cyclones this side, you call them hurricanes, right?
Yeah.
It's the same thing. Why do 99.9% of the clouds ignore the Coriolis effect? Why is it only hurricanes? All the clouds should be spinning.
No,
Every single cloud.
Clouds are not on the Earth. They're affected by the atmosphere. So,
well, cyclones. Yeah, cyclones. It's basically, if you look at the storm patterns, the cyclone's made of clouds. That's how you know it's there. That's the only thing visible to us. So you're saying that the patterns in the clouds, which make the winds visible, right? Why are all the other clouds ignoring the Coriolis effect? Why is it only storms, cyclones, and hurricanes that spin one way or the other way?
the normal clouds follow the wind patterns. They're basically light. They float in the atmosphere, so they're going to follow the direction of the wind.
Exactly.
So, in the area where I live in the westerlies. So if you look at the latitudes, the United States is kind of in the westerlies. The winds, I watch the weather all the time, and the meteorologists always say today's winds out of the west, blowing from southwest to northeast, does that all the time. practically every day. So you can see the prevailing.
Can I just mention something here? There are jet streams that are always running at the same direction. For example, aircrafts that take off from South Africa to go to Australia,
Correct.
the pilots
Right.
will use those jet streams to go that direction, but they don't come back that way because the jet streams are counter. So the jet streams are there all the time, and they go right around the perimeter. They don't come back. Okay.
The jet streams are separate from the prevailing winds because they're high up, and so the jet streams follow the rotation of the Earth because they're not affected by the friction of the Earth spinning underneath them. They're higher up. So you find there's a jet stream in the northern hemisphere that goes from west to east. The one in the southern hemisphere also goes from west to east. There's an ocean current called the Antarctic Ocean Current that goes from west to east. There's an Arctic current. It's kind of affected because there's more land up there, but it also goes from west to east.
Yeah.
Ocean currents all.
Okay, so sure. To be in the ocean currents,
Yeah.
why don't they follow the Coriolis effect? For example, some folks have said that if you on the northern side of the equator, and the water will go down a sink the one way, and if you're on the opposite side, if you're on the southern side, it will rotate the opposite way.
Yeah, that's not.
Yeah.
That is too small to be affected by the Earth. Those drains are affected by the shape of the bowl, or the bowl might have a.
Well, the point is, it's nonsense, because if the water goes down the one way, then your shower would go down the one way. If you open the tap, all water running down, waterfalls would rotate to one way on the one side. Waterfalls on the opposite side would rotate the same way. Water cannot, and the air and the clouds cannot behave differently. For example, if the Coriolis effect caused the cyclones, it would affect all wind, not just a cyclone, not just a hurricane. So there's a problem. Now, when I was younger, I was in the military. I became an instructor in the military. I fought in 3 different wars in Africa while I was involved in instructor in 3 different wars. Now, some folks will say, well, a sniper has to take the Coriolis effect into account. Now, we worked with the G5 cannon, and at that stage, it was the biggest cannon that was around. We never, ever took the Coriolis effect into account. Never. No recoilless gunner, people using mortars, whether airplanes were dropping bombs, no one took the rotation of the Earth. In other words, the Coriolis effect was never, ever taken into account. Now, I've heard riflemen say it is, but that's a lie.
So when you were firing the cannon, you took it out on the battlefield the first time you ever fired it and hit your target directly?
Yeah, they gave you the target coordinates, and it was based on the distance and the height of the projectile, not the rotation of the Earth's of the Earth. Because if that is the case, you see, it just simply doesn't add up. Because if you were firing a cannon based on the rotation and the Earth spin, you would have to work out your speed on that ball, your angle to that speed, and your target. What is your target in relation to your position? The amount of calculation that would have been given is phenomenal. Now here's another thing: the rotation of the Earth, right? Which causes the Coriolis, is the spin of the Earth of 1,600 kilometers an hour. What about the 107,000 kilometers an hour motion of the Earth around the sun? Wouldn't that also cause effects on the wind and the water and Earth? How come the 107,000 kilometers has no effect, but only the Earth spin? Because think about it. If the Earth rotates once in a 24-hour period, what is the motion of it during that 24 hours? In other words, what 107,000 times by 24? That's the distance the Earth would have traveled in the same time it did one rotation. Where is that effect? It's nowhere. We don't see it. It's just ignored.
You're looking at the linear speed of the surface of the Earth. You're not thinking about the spinning of the entire planet. The Earth turns at 15 degrees per hour. So if you look at the hour hand on your clock, the Earth moves at half the speed of your hour hand on your clock. So the speed that the Earth is moving is different than what you're thinking of. And if you're firing a cannon at a target, that target is moving at the same speed you are because it's also on the Earth. So you're on the Earth, it's on the Earth, they're all spinning the same speed. So there's no reason that you would have to worry about.
But Turbo Man, there's a big problem with what you just said.
You know, have you ever been on a merry-go-round? Someone tried to put that analogy to me that the merry-go-round going once around 24 hours is not very exciting. Okay, so this merry-go-round, we make it 10 feet, and once around 24 hours is not very exciting. But extend the bounds of the merry-go-round, or a roundabout as you call it,
to 20,000 kilometers.
100 miles, or what's the circumference?
20,000 kilometers.
The guy at the end is motoring at some 1,600 miles an hour. You can't measure centrifugal force in RPM. It doesn't work because the guy in the middle is just turning around like this, but the guy on the edge, 1,600 kilometers per hour faster than a rifle bullet. And they tell me that the guy doesn't feel that.
Yeah, and another thing.
There's a lot of sorry to jump in, guys. Sorry to jump in. I just trying to keep this track. There's a lot to say to respond to that. I think when you're talking about centrifugal force and Coriolis, there's a lot to describe. So are we okay just to give David, let's say 3 or 4 minutes uninterrupted, just to give that full explanation, and then ask him on anything that you're unhappy about? Is that okay? Because I think there's a lot to say with that. Are you okay, David? Just give you 3 or 4 uninterrupted minutes.
Sure. What you're thinking of when you're talking about the roundabout, you're talking about something that has a circumference of, 80 feet or, 30 meters or something like that. And the Earth has a circumference of 40,000 kilometers. So when you're saying 1,000 miles per hour, you can't compare that to a roundabout. Because if the roundabout's going 1,000 miles an hour, it'll be like a propeller on an airplane,
Exactly.
But exactly, Turbo Brain. That's the
point. Sorry, guys. Can we just finish that explanation, and then if we just finish his explanation, and then absolutely take him up on whatever you want on it. Yeah. But I think he's just trying to get something else out. Sorry, Dave.
When I calculated just a normal roundabout, it usually makes like 60 rotations per minute. The Earth only rotates once per day. So you're talking a whole different scale of speed here, besides the fact that your roundabout is very small compared to the Earth. So, yes, your artillery people are firing across, to somebody else, but they're only you can't fire more than like a mile away. When you talk about 1 mile out of 40,000 kilometers or out of 25,000 miles, that's just a minuscule amount. And the amount of rotation during that minuscule time is, negligible. And both of you are rotating at the same speed. So if you, on a roundabout, if you have two people standing next to each other, they don't have any problem, touching each other or, whatever, because they're going the same speed. And it's the same thing with this, these artillery on the earth. They're not going to go far enough that you have to worry about Coriolis or rotation or, whatever you want to call it.
So in other words, the Coriolis effect doesn't affect cannons. It doesn't affect bullets.
No, not for those short distances. No.
So Turbo Brain, what speed am I traveling at now?
I don't know what latitude you're at.
Okay.
The
If I'm by the equator.
If you're by the equator, it's 1,037 miles per hour, linear speed.
Yeah, 1,600 kilometers. But you saying that it's not, it's tiny. If I look at a watch face, it does that. It only moves a fraction in an hour. The point is, at 40,000 kilometer radius, right? That speed is 1,600 kilometers.
Yeah.
So what you're saying is we're not going that fast, but we are going that fast. You can't have it both ways.
Linear speed is different than angular speed. Anytime something's rotating, you talk about angular speed. The Earth is so...
what is the linear speed of the Earth? So what is the linear speed of the Earth? It's 107,000 kilometers an hour. The angular speed
at the equator,
1,600. Exactly.
And
the linear speed of the Earth, according to science, the linear speed is 107. Now here's the kicker.
Let me finish here. At the equator, it's 1,037 miles per hour. Yes. But if you're at the latitude where I am, it's about 50 degrees north. The linear speed here that the rotation of the Earth is about, 600 miles per hour. At the North Pole, the rotation speed is, practically zero. It's just hard to measure because it's just going around in a circle. So on a sphere, you can't say everything moves at 1,037 miles per hour. That's only right at the equator. So that linear speed is a little misleading when you're talking about on the Earth, because when you're firing your artillery, you may not be at the equator. You may be, people that are in Afghanistan or Iran, they're going to be 50 degrees north. So that calculation is going to be messed up totally.
Well,
the way I would understand artillery as far as somebody shooting, I'm not a shooter. I don't think I've ever shot a gun, but I think that you fire at a target and you might miss that target. So then you adjust, you say, okay, I was a little too far to the right, so I'm going to adjust my trajectory so that next time I'll hit the target. It should be the same thing with, grenades or turbo launchers. It's the same thing with bombs. If you watch the plane just with standard bombs they had back in World War II, they didn't just drop a bomb and hope it would hit where they want to. They would drop like 50 bombs, and you would see that there's a pattern of where they came out of the plane, and there's a pattern of where they hit the ground. That's because of the rotation, because of Coriolis.
No, that's on the. Sorry.
Turbo brain, no. That's wrong. If a plane is going in a certain direction and it releases a bomb, that bomb travels in the direction that the plane is going. That bomb will lose its momentum. Now think about what you're saying. If that plane was going easterly, right, so you had two planes, one flying easterly, one flying westerly. They both dropped their bombs. Their bombs cannot fall on the ground and fall exactly the same. And all you take into account is the motion of the airplane, because what about the rotation speed of the Earth? And here's the kicker.
That's what I'm saying.
At 12 o'clock midday, you have to minus that rotation speed against the linear speed of 107,000 kilometers an hour. And at nighttime, you have to add the speed of the rotation of 1,600 kilometers to the linear speed. So what's the difference between midday and midnight? 3,000 kilometers an hour.
Why is it?
So what do we do with it? We just minus it and say, don't worry about that.
If it's going east, the Earth is spinning, from west to east all the time. It doesn't change at night. I don't see a difference.
Actually, think about it, Turbo Brain. If you on that ball, and that ball is rotating, if the ball is going easterly, you on that surface of that ball. So, in other words, towards the camera is the sun. The sun is the camera. If I'm rotating this way, I'm rotating with the linear speed. But when I come this way, my rotation is against the linear speed.
Yeah. But
so
you realize
what is the difference? 3,000 kilometers.
That's
so
12,000 miles away.
Yeah. An airplane dropping a bomb in midday and midnight cannot have the same end result. The reason why the result is the same is because the Earth's not spinning. The Earth's not moving.
Because that
Can I interrupt one
what
second?
you're talking about when it's rotating this way and then going the other way, there's like 12,000 miles difference between those two. You're talking about a totally different. So, the plane's going eastward. When it's on the other side of the Earth, you're not dropping the same bomb on the same spot. You're talking about a totally different thing. So it's not the bomb is not going to drop one way and then drop a different way, because the plane is in a totally different part of the world. If you're over Afghanistan and you drop a bomb, it's going to drop a certain way. If you wait until dark, you drop a bomb, it's going to drop the same way.
Same way. That's the problem. Because Afghanistan at midnight is spinning 1,600 kilometers an hour on its angular momentum with 107,000 kilometers. So its angular momentum is 1,600 kilometers.
Yeah.
Its linear motion, 107,000 kilometers. That's at midnight. At midday, the rotation is in the opposite direction against the angular momentum.
No.
Yes, it is, because it's turning. So you're saying the world isn't rotating. Then I agree with you.
The world is rotating, but your plane, Afghanistan, everything has rotated over to the other side of the world.
The problem is that Afghanistan and the airplane is actually on the world.
If you turn it around and look at the world from the other side, the plane's still going eastward. It's still dropping the bomb. Afghanistan is still there. The Earth is still turning.
The problem is it's going easterly in the opposite direction of the linear momentum, because the Earth goes in an orbit around the sun. But what is that? Let's take that as our linear momentum. So 107 1,000 kilometers an hour.
I realize that, but let's start over Afghanistan. Our plane is going eastward. We drop a bomb, it lands wherever its target was.
Yeah.
But now, if we move the plane, Afghanistan, over to the other side, all we've done is gone around to the other side. So the plane is still going 1,006 kilometers per hour. The bomb still drops the same way. The
But
Earth
it's
is still spinning from west to east.
But it's going against the linear momentum in the opposite direction, not the same direction, because it's turning.
Do you mind if I interrupt just a second? I'm sorry to do that. And of course, it's your debate. You guys stay on whatever topic you want to stay on. I'm just maybe suggesting that obviously the Coriolis effect is a huge topic we could talk about for a long time. I'm just wondering that obviously the Coriolis effect isn't evidence for a flat Earth either. What the lack of a Coriolis, that wouldn't be evidence that the Earth is flat, for example. And I see where you're going. You're going with kind of using it to try and break down the globe Earth model, etc. I mean, do you want to keep on with the Coriolis, or do you want to? It's entirely if you've got something that's evidence for the flat Earth, or David, if you've got something that's evidence for the globe Earth, for a change of pace, feel free to do that now.
I'll give you some evidence for the flat Earth. It's simple stuff that anybody can see and observe.
Okay.
Mm-hmm. Yeah, fire away.
I'm watching a sunset, right?
Okay. Yeah.
I'm watching the sunset. If I look at the reflection of the sun on the ocean water, I'll see the sun and its reflection on the ocean all the way from the horizon all the way to my feet.
Right.
Right. We all see that. So the issue is, how can the reflection of the sun reflect on the water if that water is curved? Because the sun, when it sets, it's supposed to be 195 million kilometers in front of you. Its reflection can't be by your feet when the sun sets. But everything that, all the light on that sun would be on the opposite side of the board. Let's just add the moon to that. If I'm there and I see the moon in front of me, and I see the moon's reflection in front of me, the only way I can see that on a board, the moon has to be behind me so that I can see the reflection at my feet. Because if the Earth's a ball, the reflection of the light of the moon must be in front of me. So how is it?
I don't think that's true necessarily. When I see the Earth setting or the sun setting, the sun when the whole disk is in the sky, as it's setting, you don't see that sunlight on the water until it gets to the horizon, and then you start seeing a little bit, and then as it goes down, you see more and more. That's the same thing as you take a lamp in your house and drop it down behind the television or something. It reflects a sun ray or a light ray, and then as you go down, then when you get behind whatever you're behind,
there's a round curve. Can you see this light on that side of the glass? No.
Sure. Yeah.
You can't.
Yeah, I could see it.
And on a flat surface, you can. You see the light and its reflection because the surface is flat. Do this. That side is dark. So if you're on that curve of that ball, the light can't bend around the curve of the Earth.
But once
it's simple
again,
things like this. It's simple things like that tell us the ocean is flat.
You're looking at you're looking at in a totally different scale. I would think as an artist, you would know the scale of things. When you're standing on the beach looking at the horizon over the ocean, that's only about 3 to 6 miles.
5 kilometers.
Miles or kilometers, whatever. It's not that far. And over that distance, it's going to be the same result as if it were flat. Because
the problem is,
Can I just make a point here? A simple thing.
the problem is,
Rory, let me just 30 seconds here.
Yeah.
When you're looking at the water of the waves, this side of the wave, you'll see the shadow. It's because the light doesn't get there. And even if it's a little ripple that's 2 inches high, this side of the ripple is dark.
Yeah. Uh-huh.
If there was no waves, you would see the reflection all the way to the horizon.
Right. But remember that you're looking at only about 6 to 8 kilometers.
Okay, so I've got a problem with that, what you're saying. When the sun rises, right? If that curve is 5 kilometers, how can I see the sunrise from 6 o'clock in the morning to 6 o'clock at night? Because you saying I'm only seeing it 5 kilometers to the horizon as the sun rises and 5 kilometers back. How can I see the sun for the entire 12 hours then?
You're seeing the sun rise for 12 hours?
The sun rises and sets for 12 hours.
The sun only rises for about an hour and then it's up in the sky.
It rises and it sets for a day, 12 hours for the entire day.
Right, and it goes across the arc of the sky and sets in the west. So it rises in the east, goes across the sky, sets in the west.
Yeah, you're missing the point. That if I'm on a curve of a circle, let me draw it out here. If I'm on a curve of a circle and I can only see 5 kilometers and there's the sun, I can't see it for 12 hours. It's impossible. So what you're saying about the horizon only being 5 kilometers in front of you simply doesn't add up.
I think it does if you again.
You're talking about scale.
You're missing the scale.
Flat is flat. Doesn't matter how big it is. It's the same. A curve is a curve.
The Earth is not
that
flat.
Curve can't become flat. Sorry.
The Earth is curved, yes, but the sun is like 1,000 times bigger than the Earth. It's huge. It's far away so that it appears smaller, but the light from the sun envelops the entire Earth. So you're looking at the sun going across the sky. Yes, you're seeing the light from the sun that comes to the Earth, but you're not seeing past the horizon. The sun is up in the sky.
Exactly. You can't see behind the horizon. You can't see down the ball you're standing on. Nobody can see behind the horizon because it's a curve.
Yeah, but the sun is up in the sky. It's not behind the horizon.
At sunrise, where is the sun's position? It's on the same ecliptic plane as the Earth, the exact same ecliptic plane. That's what I'm talking about. So if Earth and the sun are on the same ecliptic plane, you can't see around the ball you're standing on. So let me illustrate something else. If I see the sun, I see it like this. I see the sun's rays left and right. Right? Anybody on Earth, you see the sun, you see the rays left and right. Well, if you're on a ball, right? If you're in the northern hemisphere and the sun is on the ecliptic plane, you cannot see the one side, the opposite side of the sun's rays on that ball Earth.
That's right.
You can only see that on a flat Earth. If I take a triangle, right, and I put a ball in front of that triangle, I can only see the side of that triangle that's this side of the ball. Yet on the earth, we see the sun's rays coming down. If you're on a ball, you can only see the one side because that's the side of the ball you're on. Where's the other rays? It's on the other side of the ball. So it's simple things like this that tell us.
No.
Right. Can we just, can I just clarify what your point was before I pass it over to David?
Yeah,
Sorry, guys. Sorry, I don't mean to interrupt again. I'm getting just a little bit lost. Can I clarify what your point is? And then we'll pass it back to David to give a response for a few minutes on that.
Yeah.
So is your argument, I got a little bit lost somewhere between the sun setting and then you seem to be talking about crepuscular rays or something. Can you just very concisely summarize your argument, and then we'll give David maybe 4 or 5 minutes just to respond to that, because again, there's going to be a lot to say. So can you just concisely just summarize it for us?
Okay, so when you see the crepuscular rays, right, you see the entire band left to right of those rays on the ocean.
Yeah.
That's not possible if the Earth was a ball.
Why is that?
It's not possible because if that sun is 195 million kilometers away, those rays must be half of those rays must be on the other side. Why? Because the ball Earth you're standing on and the sun is on the same ecliptic path. They're on the same level plane.
But the sun is immense. It's so much bigger than the Earth that the rays from the sun cover the entire planet. So 1/2 of the Earth's sphere is lit up at one time. And then as it moves around, that half moves with the Earth.
Yeah.
But 1/2 of it is...
We know all that.
You're
not answering the question. You're not addressing the issue.
I'm trying to get there.
So we just let David because I think he's trying to answer it. I think he's getting there. If we just maybe give him 2 or 3 minutes, because
sure.
and then no, you're right. It's okay. But yeah. So when you're done with your explanation, David, if you just say finished, and then we know when others can jump in.
Yeah.
So it's all over to you, mate. Off you go.
So when you see the sun rising in the east and then it's in the sky, there is no horizon blocking the sun. You're seeing directly from you to the sun. So, whatever distance it is, you see the sun. As it moves across the sky, you're still seeing the sun. When it gets to the horizon, now it's blocked so that it becomes dark where you are. So it has to travel all that direction across the sky, and when it's up in the sky, there is no horizon to block it.
Baldy Catz, I sent you an image 1. Can you load that image up? That everybody can
that'll be Creek is the technical mastermind.
It's on the screen now, Rory.
Okay, so have a look at that image. Right, this is part of a video footage, right?
Rory, sorry, let me just jump back in. Have I got the right slideshow? What was the title of you?
That's my PowerPoint, mate.
Right. Sorry. So it's slide 1, Rory, yeah?
Yeah.
There we are, got it. It's on the screen now. Sorry, my apologies.
Okay. No problem. Right, so this is a guy in the United States. He films the sunrise and orbit and set over a period of 24 hours. His video footage it's on a video clip where I show the entire clip called Flat Earth and Professor Dave the Ball Puppet. Now, he films the sunrise above his head and set. What is the radius of that circle according to what we're told?
Right. Sorry, can I just interrupt again? I don't know what PowerPoint this is that I've been sent, but it's definitely not an image. It's text on a sandy color.
That'll be David's PowerPoint. Sorry, there was remember an email with 12 images on. It was the third one down in the inbox.
Ah, right. I've only looked. Right. I've not even seen that. Right.
That's my communication skills coming to the forefront again. Everybody, sorry. Right. Sorry.
So I can't see.
Yeah.
It's a circle with a guy. It's the sun moving in an orbit path. Right. It's taken from the video footage.
I think that I've seen that video, and it's at the North Pole or near the pole. So you're watching the midnight sun as it goes around 24 hours.
No, it's not the midnight sun. That footage is taken in the United States of America.
Alaska's.
Let's have a look at the image.
There's no images there.
I can't see the image, so I'm just guessing.
Hang on a sec. There's a video, flat Earth train on a sleeper.
Okay, not that one.
That's all that's there. There are no other images, Catz.
So right, just let us. There's one with 12 on. I'm just going to forward it to you. To the agree to disagree mail, so it'll bob up as a new message in a second.
Right. Okay.
While we do that, maybe this is a good time for a musical interlude. I could do a bit of a song, or do 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 do.
I'll tell you what might cheer you up, Catz, while I'm looking for this, because nothing's come through yet. So I was live on Sunday, and I said something in my best Andy from Little Britain voice. You know, I want that one. And everybody said, "Oh, that was a brilliant Conspiracy Catz impression. You should read your comments out in that voice." Oh dear me! I thought it was highly amusing, but I've got the same sense of humour as a 12-year-old boy, so don't use me as a guy.
That is good. That's just slipped into
still
the
nothing
top
there,
of your box,
Catz.
mate. It slipped into the top of my box.
Hey.
The inbox for anyone in the chat.
Oh, right, here we go. Right, Rory, I've got it. What number image was it? Number
one.
Number one. Right. The only thing is now is how am I gonna? Because they're not in a PowerPoint. See.
No, it's not a PowerPoint. It's just a PNG.
Yeah, no, I know, and that's the problem. If they're not in a PowerPoint, I can't show them without. They need to be in a PowerPoint, really. So I've got no way of linking them to the streaming software.
Okay. So let's drop the images. The issue is that someone can put up their camera and film the sunrise.
Yeah.
And in certain places in Canada, the extreme northern parts of the United States of America, they see the sun orbit above their heads. Now, that would mean that the radius of the Earth, if the sun's 195 million kilometers away, you seeing a diameter of nearly 400 million kilometers above your head. There's a problem if the sun and the Earth are on the same ecliptic plane. You can't see that orbit above your head. It should be below the horizon.
But again, you're thinking of the sun as being the size of the Earth or smaller.
Nothing to do about that.
That's nothing about the size, nothing. It's just the width from this point to this point, 400 million miles.
Kilometers. And you can capture that in a normal 10 mil, 20 mil camera lens. So that's not possible. Not possible at all.
If the distance to the sun is only 150 million kilometers, and you've got the size of the sun at 400 million kilometers.
Double that.
That's going to take the entire Earth will be in the middle of the sun.
Correct. So how can you see that path above your head? 100%. Yet a man can go and film it, and you can film the entire circle of the Earth's orbit above his head. That circle should be below the horizon. Way below the horizon.
You got me confused. You're saying that, if I have a beach ball that's 3 feet wide And then I have a golf ball that's 1 foot inside the beach ball. That's what you're telling me about the sun and the earth. The earth is 150 away from the sun, but the sun is 400 across. So the sun is bigger than the distance to the earth. The earth is going to be in the sun.
If I'm standing on Earth, the sun doesn't envelop the entire Earth. It's small. So you're saying it's big, but it's small. That's the point is, at that distance of 195 million kilometers, its orbital path is in ecliptic plane on the same ecliptic plane as the Earth. So it's impossible for a man to form that orbital path above his head. Impossible. It's not about the size.
Can I just interject?
Yeah.
Sorry, guys, for interjecting, and I don't mean to. It's just to kind of like keep things on sort of concise and on topic. But
Yeah.
I know you're saying that it's impossible to see that. David is saying that that it's perfectly possible to see it. Can I just ask?
Yeah.
Are there any? Has there been any geometry done that you can show us? Any maths that have been done? Any kind of like to scale measurements that have been done that show this is impossible, or is it just a gut feeling that it's impossible?
No, the image that I sent you, image 1.
Right, I'm going to get that. I'm going to whack it on a PowerPoint. I'm going to send it to Creaky, and then David can have a look at it. Is that okay?
Put all of them in one PowerPoint. Yeah.
Yeah, I'll be cracking on with that. So I'm going to shoot up now. Can we just give David 3 minutes again just to answer, because there's a lot of points there while I'm putting that in a PowerPoint, and then you can call up whatever you want to. Okay.
Yeah.
Thank you.
The sun is in the ecliptic plane, but the earth is so tiny compared to the sun. The earth is near the equator of the sun in this, wherever the sun is, but the sun is so big that it has rays that completely miss the earth. If they go out over, they're completely missing the whole planet. The sun covered half of the world at the same time. So when it's daylight in the United States, where I am, it's still daylight in the south part of South America.
Yeah, I understand it. I understand that, Turbo Brain. That's not the issue. The issue is a man standing on that ball as that ball rotates.
Yeah.
If that ball's rotating on the same ecliptic plane as the sun, he can't see the sun. The angle of the orbit is wrong. Because the angle of the orbit can't be above his head. That's the issue.
I think that you're missing the way that the sun and the earth look at each other. The earth is tilted, so
correct.
When you're near the top of the earth,
yeah,
when it goes around, there's
okay.
gonna
So
be
at nighttime,
the sun.
At nighttime, can you see
Right,
that?
can I just jump in here a second, guys? I've muted Rory because he's sorry, Rory, but you're not being fair to David. You're not giving him a chance to respond. You keep jumping in and talking over him. So we'll go back to David now, and I will keep Rory and Craig muted because Rory especially doesn't seem to be able to let David answer. So David, back to you, pal.
Okay, thanks. Like I said, the sun is huge and the earth is tilted. So there is when you're at the top of the earth, you may see the sun for 24 hours if you're close enough to where it's tilting. And that's what's called the midnight sun, where in the Arctic, when the earth is tilted toward the sun at the North Pole, you have 24 hours of daylight every day for a month or more. When the Earth is tilted away from the sun, at the South Pole, you see 24 hours of daylight all the way around, for about a month. That happens. So if we were on a flat Earth, there isn't any way that wherever the South is can have a 24-hour sun, because the disk is so big, and as far as I understand with flat Earth, the South is all the way around it. So when you're talking about the little sun that goes around and shows the spotlight on the planet, there can't be a 24-hour sun on the South, but there can be on the North. So I can understand you saying that at the North Pole from the United States. But if the Earth were flat, you wouldn't be able to give me that picture from the south tip of South America or the south tip of Africa. So I guess I'm finished with that.
Okay, there we are. Rory, you're unmuted, pal. You need to...
Okay.
There we are. Cool.
Okay. So turbo brain is a problem. We don't see a midnight sun in the south.
No, you do. You do.
No, you don't.
Yeah.
I
Sure,
stay in the south. If I go down to Cape Town, I don't see a midnight sun.
Yes. Yes, you do see a midnight sun.
Turbo brain, I live here. We go all extreme Cape Point. There's no midnight sun. You telling me that we do see it? No, we don't.
You should if you're not close enough. I've never been to South Africa, so I don't know.
Exactly. So don't tell me you do see it, and I'm telling you we don't.
Okay, if you're on the coast of the ice wall or the coast of Antarctica, there is a 24-hour sun.
Yeah. So why don't people in Chile see it? Why don't people in Chile put up their cameras and film the midnight sun from Chile? The bottom end of Chile.
They should.
No one's ever filmed it, but you're saying it's there. We've never seen it.
I've seen it from Antarctica. Yes, I've seen video.
Yeah. Earlier you were speaking about the tilt of the Earth, right? At 66 or 23.4 degrees, right?
Right.
So the problem is, how can you see the orbit of the sun go above your head? Because what you're missing out, Turbo Brain, is that the sun's position is fixed at 195 million kilometers away. It's in front of you. That sun cannot move above your head if it's in front of you. You're doing an orbit. How can the sun move above your head?
Because you're moving in an orbit. It's not the sun that's moving.
You're doing an orbit on the rotation of the Earth for the midnight sun. Right. Where's the sun? It's in front of you. So, in other words, if the camera is the sun and you are on the Earth, doing an orbit like this, right? The sun is still there. The sun can't come above your head and do this.
No, but hold up your tape there again. Hold it up. Now tilt it toward the camera.
Right.
Now spin it around and you'll see that it sees the sun.
The problem is that this is flat.
Sun.
This is flat. It's not a ball. You can't see around a ball you're standing on because it's a ball.
It's the same thing.
No, so a ball and a flat is not the same thing.
I can't explain it without showing you. I would think as an artist, you would be able to visualize in your mind's eye a tiny little planet and a giant sun. And so when the planet is tilted like this, as you go around the top, you're going to, it's like one of those tilt-a-whirl things.
Yeah, the problem is, Turbo Brain,
you're going to see the 24-hour sun. If the sun is down by the equator, if you're standing on the equator, you're going to go around. The sun is going to be hidden behind the Earth if you're on the equator, so you're not going to see the sun 24 hours.
Agree to disagree. Do you want to mute Turbo Brain because he's not allowing me to speak?
Okay.
To be honest, I think Turbo Brain's been very polite tonight. To be honest, we're not the kind of show like Nathan Oakley's who will start falling out and shouting. But
let me just make that point, because what Turbo Brain's saying is not true. He's saying that if you're on a ball, and he's saying if I'm an artist, I would get it. I am an artist, I get it. The whole point is, if you're on a ball, you can't see around the curve of the ball. For you to see the sun has
to be fair, let me if I can just interrupt. I think there's been something lost in translation a little bit. I don't think for a second that David has said that the sun is going around the opposite side of a ball. He's not said that. And maybe it's a language barrier or something, but that is the exact opposite of what he said. What he said is because the Earth is spinning on a tilt. When you are near the North Pole, for example, and I don't want to take David's argument away from, but it's because the Earth is spinning on that tilt that all the parts of the ball then presented, if you like, to the sun. Would that be fair, David? Is that what you're saying?
Yeah.
But you know what the problem is? Baldy Catz. The problem is you're on a ball. You can't see around the curve of the ball you're standing on. He keeps saying that the sun is huge. The whole point is it's 195 million kilometers and it stays in that position. The same distance.
I think with that bit, I think something definitely has been lost, because I think everyone watching, and myself included, I think we all can hear what you're saying. You're saying that if the Earth is a ball, the sunlight can't go around the other side of it. Okay, and I think David's agreeing. Yeah, and I think David's agreeing that the sun won't go around the other side of the Earth. The light won't go around the other side of the Earth. But I think maybe it's just the language barrier or something. He's definitely not saying what you think he's saying. He's definitely not saying that. And I think if you listen back, you'd hear that so what I'm going to do is I'm going to give it back to David just to be concise with his point now for 3 minutes, just to tell you exactly what it is he is saying, and then you can address that. So I'll go back to you, David, because he's definitely not saying what you think he's saying.
If you take your beach ball and tilt it at 23 degrees and point it at your light is going to see all the way around because it's tilted. So it's like you're getting a tilt. So you're seeing, if you're high enough on that ball, you're going to see the whole sun all the way around. If you're lower down on the ball, down by the equator, as you go around, it'll be daylight. When you come back around the other side, it'll be dark because the sun is hidden behind the Earth. That's what I'm trying to say. So
can I just say, so the sun is 5 degrees, or everything's off 5 degrees off the ecliptic. So the tilt of 23 degrees is not enough for the sun to be above your head. You would have to tilt that Earth 60, 70 degrees before the sun's even going to be anywhere near your head, if the sun is 5 degrees off the ecliptic.
But it's not at your head. When it goes around, it's up 24 hours. It's only above the horizon about 10 degrees,
No, it's not.
Maybe 100 miles.
So the brain goes right above your head. So
sorry guys to keep stepping in. Sorry guys to keep stepping in. And I'll give you that next point, but I just think we've got to a situation now where it's a bit of a dead wall. I think one side is saying it's not possible, the other side is saying it's possible. But at the end of the day, without a proper breakdown of the maths and the distances and the geometry, all we've got is our own personal opinion. I think if we just keep saying to each other it's possible, it's not possible, we're not going to move on with it, if that makes sense. So I'm just wondering if we can move on to...
Can I answer Turbo Brain's thing about his illustration with the ball?
Okay, you answer that, and then if maybe we go to David to bring up a point he wants to discuss. So because I think you brought up the Coriolis and the
The
and
midnight
the sun, right? The midnight sun. So if you answer David's point, we'll go to David and let David bring up a globe proof for you to talk about.
So here's the beach ball, right? If I put a black dot on that beach ball right near the top, and I'm rotating that beach ball, remember, you need to see the sun for the entire rotation of that orbit. If you're on that side of the ball, you can't see the sun through the ball you're standing on. That dot would represent your position. You would have to be standing right at the North Pole.
You would.
Now, people see the midnight sun 500, 600, 1,000 kilometers from the North Pole. How come? The ball Earth is in the way. So when they film it, that guy's camera is at a fixed position. He sees the sun way above his head. The sun is in the wrong position. That's the issue with the midnight sun. So Dave's illustration about the ball, the beach ball, remember, you need to see the sun for the entire 24 hours, the entire one rotation.
That's your point. We get that, and I think we'll again agree to disagree on that one, or you two will agree to disagree on it. But because without the maths or anything, we're going around in circles. So we'll pass it to David. And David, is there like a globe proof you wanna bring up, something for the guys to see if they can debunk or dismiss?
I can tell you kind of my favorite one about the globe is that I went to a website that keeps statistics, and it has surface area for every country in the world. Each country reports to this agency their surface area. They do it every year. So I saw data from 1962 to the present. So it is repeatable, but we have surface area from each country over the entire planet. Then, so I added that up. If I add up all those, there were 205 countries. I added all those numbers up. Then I had to go to a different agency. I think it was NOAA, the Ocean and Atmospheric Administration. They have data for surface area of 18 of the major seas and oceans around the Earth. So I added those in. What I got was a number for the surface area of the Earth. I didn't have to assume flat or globe. All I did was take surface area numbers for the land, surface area numbers for the water. I added those all up. So I got a number without seeing it in front of me. It was like 1.9 times 10 to the 8 square kilometers. So what I did is I took just a geometric sphere, just like you draw on a piece of paper, a sphere, and you can calculate its surface area if it has the radius that we know the globe has, or that the commonly accepted radius of the Earth. You can calculate the surface area and use 4/3 pi r squared, and you get the surface area of a sphere. That surface area that I got was exactly the same number as what I got with the numbers I added up statistically. Then I thought, well, I need to check the flat. So I took a flat disk.
Yeah. Sorry, I just want to get something straight here because I'm not understanding. What you're saying is you took that surface area and you based it on what? On a circle that you drew on a piece of paper. That's flat. That's not a ball.
Well,
So
I'm
not understanding.
I just meant I'm not doing the Earth. I'm calculating the surface area of just a sphere, like I would in geometry at school.
On a circle. You can't do that.
A sphere. I did it on
a flat circle.
a sphere.
A sphere is a circle on a flat piece of paper. So
That's
your geometry is going to be wrong.
No, that's a
Because how
circle.
can you do a geometry on a flat piece of paper on a circle? Because a circle's flat.
I did.
So your geometry is wrong.
No, I did the calculation for a sphere. I don't understand why you think it's a circle. I'm talking about a sphere, like a ball, like a basketball or a soccer ball. And you can calculate the surface area of that ball using
on a ball.
Right.
Yes. On a ball, you can't do it on a circle on a piece of paper.
No, Rory, I think what he's saying again, and I know it's possibly a language barrier thing. So
No.
and you're doing far better than I would, because you're doing far better than I could in different language. But what he's saying is, he's mentioned that he's drawn a circle, a globe or a sphere on a piece of paper, but that is irrelevant to the maths and the geometry he's doing. What he's saying is, when he's done the geometry based on a sphere. He's done geometry based on a spherical shape. Now, he's not a model maker. If he's going to represent that and draw you a picture of it, that's going to be on a flat piece of paper. But he's saying the maths he's done has been based on geometry. He's not a model maker.
Baldy Catz, that's the point. The maths would have to be done in a 3D program, in 3D software.
No.
Not necessarily, but I'll pass you back to David for that.
I'll prove it to you now. Let's just take...
Well, hang on. Can we just hear what the experiment was first of all, and then you can debunk it? So let Dave finish what his experiment was, and you come back and you give your debunk to it. So, David, if you carry on.
What I was thinking is, I wanted to take surface areas for the Earth, just surface areas. I'm not saying that it's a sphere or that it's flat. All I want to do is take some numbers that were reported to an agency that records all this stuff. So I took those, added them all together, and I got a number for the Earth, whether it's a sphere or not. So that number that I got was just calculated from some other numbers. So if we set that aside for a moment, I want to decide, is there a way to tell from looking at that data, can I tell if it fits a sphere or if it fits a flat disk? Okay, so the first thing, I took a sphere in geometry, and there is a formula in geometry to calculate the surface area of a sphere. That formula is 4/3 pi r squared. Okay, so I use that formula. The r would have to be the radius of this sphere, that is the size of what I think the globe is. So I did the 4/3 pi r squared. I got a number. When I took that number that I got, it was like 1.9 times 10 to the 8 kilometers squared. I compared that to the data that I took, and I also got about 1.9 times 10 to the 8. So then I still have to look at the flat Earth to see how it compares. So I took a flat disk, the flat map that you guys all use, that AE map. You have the North Pole that's at 90 degrees. If you draw a line to the equator, that the equator is 0 degrees, so you've gone from 90 to 0. And then if you go from the equator to the southern edge, that's also 90 degrees. So I have 180 degrees from the North Pole to the edge of the circle. So each degree, you can look it up anywhere, each degree of latitude is 69.1 miles. So I multiply that 69.1 times 180, I get a number. It was 14,000 something. So now I can take that radius, that's the radius of the flat Earth disk. I can multiply it by 2 pi, because 2 pi r is the area of a circle. So to get the flat Earth surface area, 2 pi times that radius, and it gave me 4.3 times 10 to the 8 kilometers squared. So basically, what I found from this calculation is that the flat Earth disk is going to be twice as big as the data that I got from each country measuring their own surface area. So that's my conclusion of that experiment.
Okay, so can I ask some questions here?
Yeah,
Sure.
Your turn now. Fire away.
So let me just get this just doesn't add up.
It's a lot of math, yes. It's a lot of math.
No, the math don't add up. Your story don't add up. I'll tell you why. So you went and got all the water surface area, right?
And the land.
And the land mass, the surface area of that land mass, right?
Right. Exactly, yes.
So the data was in what format?
It was in square kilometers.
Square kilometers, which is flat. Not cubed, flat.
Surface
Correct.
area is flat.
Correct. 100%. Flat. So what does that tell you? There's a problem.
You can still calculate surface area.
Why didn't you? So that data that you got from all these countries and all the oceans and blah, 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 they gave it to you in a flat map. Show us that flat map. Let me see it. Because if it's a Mercator map, then it's wrong. Because
No,
the
they
land masses are all distorted. So it wasn't a. So what map was it? So the map sounds interesting. Show me that map.
They didn't give me a map. They gave me numbers.
Exactly.
So all I had is a column of
was
numbers.
for a square surface area on a flat surface. And you just bend that surface into a ball. What does that prove? Nothing. I'd like to see that map that you got.
I can show you the numbers.
Simply doesn't add up.
I can show you the numbers and everything that goes with it.
Yeah. Well,
I'll send it to.
the issue that you're trying to describe, turbo brain, has been a problem for thousands of years, for hundreds of years, is making a flat map from a ball. And it cannot be done.
That's right. It cannot be done.
Cannot
I agree.
be done. There you go. But you saying you did it.
But no, I'm not saying that.
You did. You said the math all blah, blah, blah worked out and it's brilliant, dong, there it is. Scientists say it can't be done. There's a problem. That you cannot
There is a
take
problem.
land masses.
Each each country has a surface area, and they can send surveys out and measure that number.
Yes, and they make maps. So what is the map that they give you? The Mercator map, and it's wrong. And they tell you it's
Oh,
wrong.
can I just jump in, Rory? David has made it perfectly clear that all he was provided with was a set of numbers. There was no map, so he cannot show you something that he doesn't have. And he has said that repeatedly, that it was numbers, not a map.
Yes, but the numbers are related to a flat surface area.
Yeah.
That's the problem.
But that's the
Sorry.
only way.
Okay, sorry, can we just talk about Polaris, just to change the subject a bit?
Yeah, let's do that.
Okay,
I
Polaris.
want to talk about Polaris.
Okay,
We're going to
so-
have about 10 minutes, guys, just before we wrap this up. That's all. About 10 minutes.
Oh, thank
Okay,
you.
so according to the heliocentric model, the North Pole always points towards Polaris.
That's right.
Okay, 6 months later, after the Earth has traversed around the Sun and is on the other side of the Sun, the North Pole is still pointing at Polaris, being the
right.
Earth tilted at 23 degrees. So the
Right.
Earth now has traveled 186 million miles, and yet it's still pointing at Polaris. And the interesting thing is, the Georgian guide stones, one of the stones has a hole in it, and it is pointing at Polaris 365 days a
A
year.
year.
How is it possible when the Earth has now moved 186 million miles?
Other
way-
side.
The way that scientists figured that out is that the only way Polaris can always point at the North Pole is if Polaris is very far away. So
Okay, sorry.
So when I'm driving in my car on the, going on a trip, if I look at a mountain that's, 300 miles away on the, I can just barely see the peak, it's not going to move very much while I'm driving. The mountain that's right by the roadside, it's going to move a lot. As I drive by, I will see that mountain move a lot. The one that's way in the distance, it doesn't appear to move very much. That's because of the distance. That's the reason why Polaris always points, or the Earth always points to Polaris, because Polaris is so far away that going around the sun is just a little puny podunk of a distance compared to the distance to Polaris. So, if I'm talking in millimeters down here, and I'm trying to measure a triangle that's, 50,000 miles on the side, those millimeters are going to be very hard to show a difference. And that's the way the sun is when it goes around the Earth goes around the sun. That distance of that circle,
Okay. All
very
right.
small.
So you were saying that's what the scientists have come up with, because they are working backwards. And whenever the numbers or these problems become too evident, they just add more and more and more and more numbers just to make the thing seem so distant that it's incalculable. And it's, what is it? One guy always said millions and billions and trillions of illuminated snowballs. You see, it just doesn't make sense, and you just got to stretch it so that it becomes too small.
Yeah. Well, can I just say something to what Turbo Brain said to debunking?
Uh-huh.
The problem is the Milky Way and the Southern Cross. So let's take the Earth in a position where in the northern stars above in the northern hemisphere, a person in the southern hemisphere, he's looking in the opposite direction
That's
He
right.
sees the
yeah.
Southern Cross. So they both look to the horizon and they see the Milky Way. So you've got 3 points, reference points: the Southern Cross, the Milky Way galaxy, and the Southern Cross. Problem is, 180 degrees later, or 6 months later, where are you? You're on the other side of the sun, pointing away from the sun.
Yes.
Correct.
But you're still.
How can you see them? Because you're on the other side of the earth.
There's still this little tiny distance compared to the distance to the stars.
Trevor Brain, you're facing the wrong way. That's the problem.
I think
You're facing the wrong way. At nighttime, you're facing the opposite way to the sun.
I think if
You can't see. You can't see the Southern Cross, the Northern, you can't see the North Star, you can't see the Milky Way galaxy, and you can't see the Southern Cross because you're facing. Say, if I'm facing you now, 6 months later, I'm facing this way. No matter how far away you are from, your face in front of me. That's the problem.
Rory, and I don't mean to interrupt.
The
Sorry.
story of yours being so far away just simply doesn't add up. It's nonsense.
I think
Face
that
the opposite way from you.
Okay.
you're still
Sorry,
not looking at
it
the
just simply doesn't add up.
scale. Still not looking at the scale, and you don't realize that Polaris is in a different part of the sky 6 months later, but it's still there. The Southern Cross is in a different part of the sky, but it's still there. You in the Southern Hemisphere can still see where the Southern Cross is. Although me in the Northern Hemisphere, I never see the Southern Cross. I've never seen it. You in the Southern Hemisphere, you've never seen the Polaris. So the sun is pointing at
So you said that already, but that doesn't answer the question. The thing is, you are facing the opposite side of the universe. You should see different stars, but you see, well, we in the Southern Hemisphere see every night, we see the Southern Cross.
Can I just jump? I'm sorry, guys, just for this. I know Rory's had a connection issue there. I think he's dropped, and we haven't got a lot of time left. Can I, Great Believer, while you're here, can I just ask you, have you got a spinny chair like Rory? Can yours turn around?
Yes.
Yes. Okay. Can you do me a favor? Can you just look up at your ceiling?
Yeah.
Yeah. Now, can you spin around so you're facing the other way?
Yeah.
Can you still see the ceiling, the same part of the ceiling?
No.
That's what David's trying to tell you. I think that's what David's, because we haven't got a lot of time, but I think that's what David's trying to say. So your ceiling in the sky is the set of stars, and you've spun around and you can see the ceiling. But I'll pass you back to David. I don't want to interrupt, but I'll pass you back to David.
You can't see David there. David's gone beyond the horizon.
Yeah, David, tilt your laptop. You've disappeared now. You have the most fantastic mane of hair, and I'm very jealous, but there we are.
I have a nice recliner here. So. What you're seeing, when you look at the North Pole, remember that this Polaris is close to where the Earth is rotating. So as the stars rotate around, you've seen those pictures of star trails, those circles that are going around. Polaris is always right in the middle. As you go 6 months, that middle moves to another part of the sky, but it's still there. You can still see it. And the Earth is still pointing at it, even though you personally are seeing a different view of Polaris. So,
okay, can I make a suggestion? I know we're out of time here. With this flat Earth thing, there's so many little things that we need to discuss, and we can't discuss them all just over even 2 hours. We should actually say, let's talk about the Polaris, maybe for half an hour. and another subject for half an hour in another segment, just so we can cover it properly. And the video that we showed you there, that we sent you the link to about the train wheel, that is very interesting. And we need to maybe look at that video, maybe post it, let people look at it, and then we can come and debate that.
That sounds good. We should try that.
You're both welcome back on if you want to choose, if you want to communicate by email and you want to choose this very specific topic, and then we'll dance around and you both come for that topic, welcome to reschedule another one, the three of you, and you can come back and do just that one topic if that's what you like to do.
Yes.
Yeah.
Okay. We'll do that.
Well, we are getting late. I want to thank you both for. It looks like Rory's internet has gone. He kind of froze before he dropped out, didn't he? So
yeah, he did. Check your WhatsApp as well, Catz.
And
obviously, don't answer live on stream.
Yeah,
I'll have a kebab. Yeah. So we'll probably call it a day here, but honestly, you're welcome to come back and take a specific topic. So I'm in touch with you both anyway, and you can come back and you can do that one topic. I think that'll be fantastic. David, for your first debate, I want to thank you so much for coming on here and doing that. It's not easy 2-on-1 for your first debate, so thank you so much. That was not easy.
Yeah, thank you, Craig, Rory. Thank you for discussing. I appreciate that.
And thank you for your time as well, Turbo Brain. And we look forward to the next time we can debate something.
Yeah, good. Thank you, Craig.
Drop us an email after the or a tweet or a Twitter or a tweet or whatever the cool kids call it these days. Drop us one of those after the show, and we'll choose a topic and we'll get that set up. Because I've got a feeling that there's a lot more that you probably want to say to each other, and like you say, there's just so much, and time's beating us, isn't it? But maybe if you choose one specific topic each, we'll do 45 minutes on David's topic, 45 minutes on your topic, and then we're very specific. How's that sound?
Okay.
That's great.
Thank you,
guys. Thank you.
I've
got a quick thing I need to say here, and then we're wrapping it up. But thanks, guys. I'll see you later. Thank you both.
Okay.
See you later. Thank you so much.
Good night.
See ya. Thank you, David. Thank you so much.
Thank you. I'm gone.
See you later, mate. Well, there we go.
Just the two of us.
So if you look up, can you see your ceiling?
I'm really short-sighted, but I'll give it a try.
Yeah.
I can see my ceiling. I can see the lamp.
Yeah. If you turn around, does it vanish? Still. Oh, but your microphone is it?
I nearly broke my big furry end then.
But excuse me. Oh dear me. That was David is brilliant. He's been a subscriber of mine since he started, and he's an extremely intelligent guy. I think he said at the beginning, he's like postgraduate trained mathematician. Yeah. And I saw his opening speech. Should we, before we get to the final bit we're about, have we got any super chats you want to read out?
We have got $10 US from B-Ball for Life. How can somebody looking south viewing the Southern Cross in South Africa and someone in Australia also looking south view those exact same stars while looking in a totally different direction?
Yeah. Exactly.
£4.99 from Wade Watt. Can the Flat Earther give us a map with a scale, please? If he likes maps and scales so much. Probably not, but he's not here to ask anymore.
No. I think, and I won't dwell on specifics with him for that, but I think the arguments that they were making, that it's impossible to see, the sun or what it just seems to be personal incredulity. There didn't seem to be a reason why it should be impossible. There didn't seem to be a mathematical explanation of why.
And I found myself, obviously I'm the dumb one of the bunch, but they have no idea what scale is and how it affects what you're looking at or what you're experiencing. Even somebody who's as science illiterate as me the sun is bloody huge. The Earth is a tiny little dot, so of course it's always there. The reason it goes dark is because we turn away from it.
So, but doing? Have you been to the sun?
Exactly. But yeah, do you know what I mean? And they just seem to completely discount. The thing is, and this is going to sound like such a flat earth thing to say, but he's presupposing that the Earth isn't a globe, isn't he? By making that statement. €10 super sticker from the lovely Crafty Keeler. Thank you very much indeed.
Thank you, Crafty.
$2 from Stephen Steen. Congrats, Creaky, on his Trump vote yesterday. I don't vote for anybody in the UK, let alone anybody in America. $10 US from everybody's favourite American veterinarian, Christopher Shapley, DVM CVA. Little bit of channel love and support. And we need it after that. So anyway, Katz, why are we still here?
I don't know. Is there anything we should talk about, do you think?
Quite possibly. Quite possibly.
This will be, because I'm not a drama queen, this will be the only time I mention it, and that is it. So if anybody ever asks me about it, and I just don't mention it, this is it. This is like the 10 minutes of time. And I know some people have been in the chat and said, what's the story? Okay, but since Saturday night, I've had a considerable number of messages, and there's been a considerable number of videos released, which has sparked a considerable number of messages. And Creaky's gone. He's gone. I was going to ask him if he knew what they were. See you, Creaks. Right. I guess I'll just crack on with it then. So, I had a considerable message because I tweeted out a screenshot of a conversation that I ended up having, not by choice, with a certain sleeping warrior in a Skype group. Now, a bit of context behind it, because I've had a lot of people asking why I did that and what the context behind it was. Now, if you haven't seen the screenshot, if you go to my Twitter account @CatzConspiracy, then you'll see it, and you'll see exactly how you'll see exactly why I tweeted it out. But still, here's the context. A while ago, I was watching the Really Woke show when the lockdown was on, because they were on every single night and they were talking about interesting non-flat earth related topics. They were talking about Black Lives Matter movement. They were talking about Antifa, and it was an interesting show. So what I did, Creaky's back. What I did was I subscribed to it to watch it, and I engaged with the people in the chat. No problem. Everything was absolutely perfect, absolutely friendly. And they put a link in the chat to a Skype group for all the supporters of or subscribers of the show, whatever, to go into that Skype group. So I became a member of that Skype group, and I had no problems whatsoever. I didn't post a lot, and I think there's even somebody in the chat now, and I won't call them out on it because I don't want to. They might not know, but there's a member of that Skype group in this chat now. And I had absolutely no problem speaking to anybody in there, not that I posted regular. Anyway, lately I've been using it to go in and ask people if they want to come and debate on this channel, because they are obviously full of flat earthers. And we had the guy I debated about the virus a while ago. He was in there. I went in and I asked. Anyway, cut long story short, I went in the other night and I made a post, and a certain sleeping warrior decided that I asked, does someone want to come and have a debate on flat earth? And a certain sleeping warrior popped up in the group and started being highly insulting, as he normally is. And I repeated my offer to sleeping warrior, which was, at the time he made the video accusing me of being something very, do you remember what it was? Can we say the word? Creaky?
Paedophile.
Yeah, so essentially, Sleeping Warrior if you weren't aware, made a video a while back saying that it was all right to think of me as a paedophile. Because the guy's a moron, what can I say? So I made an offer to him at the time, and I said, I'm not going to talk to you again. I'm having no connections with you again. What I will do is I will box you. Let's get in a boxing ring. Let's do it for charity. And I'll teach him his lesson in the boxing ring. He didn't want it, and I didn't make that public. I didn't go around making videos calling him out. I did none of that. I didn't make it public because I think that would have been a bit cheap. So I just left it, and he deleted the comments where I asked him for the boxing match, and I said I would never speak to him again. So I went into the Skype chat on Saturday, and I asked, does anyone want to come and have a flat earth debate? And he popped up, and I said to him, I'm not talking to you unless either A, you apologise for analogizing with the paedophile, or you step up and you have that boxing fight with me. And that was it. He just carried on being what do you call it? A dick with his comments. And I ignored him while I was trying to set up a debate with somebody else. I didn't reply to him or anything. And he kept on and on and on and on. And I was ignoring him and ignoring him. He kept using that paedophile word. He thought he was being clever. And what I should have done was just probably leave the Skype group. What I did do was call him a pussy and a prick and offer to box him again, and he wouldn't. Now, maybe I shouldn't have done that, right? It's not something I'm proud of, but to be honest, there's a line, and on that night he crossed it. And I wasn't going to speak to him, but that's what I did. I reacted, I called him pussy and a prick and said, if you're going to box me or not, walk away. To which he responded by, again, basically making out that I was some sort of paedophile, and that was what was in the tweet. So that's the context of the tweet that I sent out. Now, Ranty's done a video on it, Mr. Sensible's done a video on it. If you watch Ranty's video, you can actually see the tail end of me. I think I called one of his friends a pussy as well, because he called me a groomer. So it was all very childish. It was all very, very childish. But that's the context of it, and I'm not proud of it. I'm not proud of, losing my cool and calling Riley a pussy or a fat prick or whatever I called him. But I think there's only so many times someone can use the word paedophile in my direction before I draw a line in the sand, and that's it. Anyway, Riley's gone very, very quiet on it, and I will not be addressing him again. And even now, even the offer of doing something for charity and meeting him in a boxing ring is gone. I'm not having anything to do with him. I'm not speaking to him. If you look on his channel now, his channel is being absolutely, he's deleting comments left, right, and centre. And I could show you 15, 20, 30 messages where he's used the word paedophile in my direction in the past. So that is exactly what the context of the situation was. And was I innocent? No. I called him a fat prick and a pussy. But there we go. Not proud of it, that's what I did. What do you think about that, Creaky?
I won't say live what I think about it, but I may chat to you about it later. But why aren't I appearing on the screen? Oh, never mind, it doesn't matter.
Oh, I don't know, mate.
No, I know. What have I done? There we are. Yay. Hi. It just goes to show the depths that somebody, a fat slug like Anthony Riley will stoop to try and, in their mind, get their point across. And I don't understand what the obsession is amongst the flat earth community with that word anyway. I don't understand. The earth is flat, so you are a...
Yeah.
That's kind of what they're saying. So, to be realistic, it makes about as much sense as all their other arguments, really, doesn't it, Well,
there's no substance at all. No. I mean, one of the things he said was, I'm not saying you're a paedophile, but if gravity exists, then you're a paedophile. It's like...
Yeah. It's just childishness, isn't it? And the thing is, you said you're not proud of losing your cool. At the end of the day, for the way I'm viewing it is, he sort of beat you to a pulp, and then your retaliation was to only kick him in the shin. It's... So, do you know what I mean? The fact that you lost your cool, I think is... Well, I'm all for it. And I wish I'd been there to see it, to be completely honest, but... I've never understood the flat earthers' obsession with that term.
No, it doesn't. To me, you've got to be thick. I'm going to be honest. If you think that using that term in any kind of context, that you think you can then get away with afterwards, you've got to be thick.
Yeah,
and
thicker than a bull's knob.
I think it's simple as that. Yeah.
Yeah. Do you know what they are? But do you know what it comes down to? That schoolyard argument mentality, doesn't it? I'm not winning. Oh, you smell, and kick you in the shins and run away. It's that kind of arguing technique. Much like
Jeez.
mine.
But I didn't like, from my point of view, I'm 100% honest, I didn't really want to react to it or anything, because at the end of the day, you know, I make videos where I have a bit of banter and I point and laugh and have a bit of, you know, I take the piss out of people a bit. I don't do it anything to that level, but I don't want to be someone who the first time I get a bit back, I overreact, you know, and I haven't. And it's, you know, every single time I've gone in, I've to that group to ask someone for a debate, it's been the same thing. Same thing over and over. There's only so many times he's going to throw that word in my direction.
Yeah.
But I'm sure I'm positive he will stop now.
And isn't
100%.
Anthony Riley a self-proclaimed expert in British law?
Oh, he's an expert.
So
He's an absolute
surely he
expert.
would be aware that what he said to you could be considered to be an offence.
I think he, when you check on his channel, I think many people posting on his channel have made him aware of that, even if he didn't know. No, not that I'm going to go down that route, but I think you get to a point where I think he just will not do it again, is what I'm going to say. I just think he will not do it again. But that's it. So for the people who were in the chat asking about what the situation was, saying why was I speaking to him after I said I wasn't going to speak to him again or any of that, I wasn't speaking to him. That was the context of how it all happened, and that's it, done and dusted. So dealt with, won't mention it again.
Yeah,
Done.
put it to bed. Don't let it consume you, because he's kind of won then, hasn't he? If you go any further than discussing it here now, I think you've done what you needed to do, and you've done it in the respectful way. So you can sniff my furry balloon now. Crafty Keeler's made a good point in the side chat. The issue is, Catz, if he gets away with calling you that, what will he do to the next person, and how far will he push that label on you?
I'm pretty sure he won't continue to push that on me. I'm pretty sure he won't. But if he decides to use those same terms for somebody else that doesn't do what I do and doesn't deserve any backlash whatsoever, then, you know, I think I can guarantee there'll be knocks on his door.
Yeah,
if
as
it's
there
for someone
should
else.
be. As there should be. That's half the problem. See, is they think that they can just get away with saying anything they want to, and eventually somebody's going to have to call them on it. You know, especially to the level that Riley's taking it to.
Yeah, and it's nothing to do with the argument. It's not banter. It's not funny. It's not clever. You know, and it's, I don't know, but like I say, it's just a sign of being thick. You know, as is repeating the words over and over again. Show me gas pressure without a container.
Yeah.
You know, despite however well an answer's articulated to you, just like it's a form of Tourette's, just saying it over and over and over because you don't understand the words that are going in. But that's it. It is done. It is dusted,
Exactly.
and I won't mention it again from now. So what we're going to talk about.
Brenda says he will continue. Don't be so naive. Call him on it now. You have to, just because.
We're going to go and talk about that again.
We'll I wanted to read that out because I've been trying to not interrupt you and to remember to read things out. Moving on, we have a super chat from Weird Watts again, $4.99. Ranty did defend you, Catz, in his video, and some FE people are defending you, so it's not an FE thing. I'm not FE, just saying.
No, it is a fair point. That is a fair point.
Yeah,
that is
exactly,
a fair point.
exactly. But unfortunately, you know, people tend to get tarred with the same brush, don't they? So if one flat earther is, well, it's more than one, let's be realistic about it, abandoning that term around, then, you know, mud sticks.
Well, it does, doesn't it? It does. Exactly. And I think, you know, people don't want to be, like Ranty said in his video, they don't want to be associated with that. You know, they don't want to be associated with people that use that language, throw it around.
Yeah, exactly. You know. Exactly. But there we go.
But yeah, so there we go. So just about time as well, 9 o'clock.
Yep. So on that on that note, thank you very much indeed. I'm going
to spend the next half hour looking at the ceiling and see if it disappears when I turn my chair around.
Oh, dear me. Have you got anything else to say, Catz?
I have. Gary Io, thank you very much, has just bought us a beer. Thank you very much. Super chat just bobbed in as I was looking at the
Thank
screen.
you very much, Gar. Very nice
thank
of
you
you,
very much,
old
man.
chap.
Yeah, really, really appreciate it. No, I've got nothing else to say other than hopefully I'll get a video out this weekend. Because I'm doing that again now, making videos again. So have you got anything for now?
I had a
I'm
video
trying.
come out at 5 o'clock today. I thought I would slip one in on a Wednesday and see what sort of reaction I got to it. So I'm quite excited to go and check how the video is getting on. And it's my first ever top 10 video. And I promise I didn't copy Professor Dave at all. I swear that I saw Dave's video just before this live stream started, after I'd recorded mine.
I think, is Professor Dave just done a top 10 video?
No, he did one. His top 10 videos got nearly 2 million views. And again, that had nothing to do with why I wanted to do it.
How many more have you got before you get to 2 million?
A lot. I'll just be happy to get to 50,000 cats.
I'll give it a view.
Give it
million
a
times.
view. Every little helps, as Asda has taught us. Or was that Tesco's? Oh no, it's Tesco's, isn't it? Anyway, it doesn't matter. Other supermarkets are available. Right, we definitely going this time because I'm waffling. Thank you very much to everybody who super chatted. Thank you very much to everybody who's made it all the way to the end. And we will see you next week. Hopefully. Where's the end button? There it is. The one with end written across the middle of it. Bye.
See ya.